From your TI Inspire lab, we derived the following equation from the locus definition of a parabola, which is y equals 1 over 2 times the quantity n minus d times x minus m squared plus the quantity n plus d over 2, where you were given this picture where our focus was the coordinate m comma n, and this was true for every xy on the parabola. Well, if we match this up with the equation of a parabola that you're accustomed to from an Algebra 2 trig definition, y equals a times the quantity x minus h squared plus k, we can line each of these up so that our a is equal to 1 over 2 times the quantity n minus d, your h is the m coordinate, and your k is the n plus d over 2 value. Now, what if we decide that we want to talk specifically about the following parabola? What we've done in this parabola is we have specifically moved the vertex from just being an arbitrary place someplace on the graph to specifically the origin. So my values of a, h, and k are going to stay the same. My a value is going to be 1 over 2 times the quantity n minus d. My h value would still remain m. My k value will still remain n plus d over 2. But this is what changes. We are going to define the distance between the focus and the vertex as a distance of p. And since the vertex is equidistant from the focus and from the directrix, then it means this is also a distance of p. So where f used to be the coordinate mn, now it's going to be the coordinate 0p. And where my directrix we just used as a variable d, now my directrix, if I was going to graph this, would be the opposite of p. So when I put these values back into the formula, where my n is now p, and my directrix is now an opposite of p, I get 1 over 2 times 2p, or 1 over 4p. M is now 0, so h is 0. K is equal to n, which is now my p value, plus the directrix, which is an opposite of p, all over 2. So that is 0. So if we go back to the equation of a parabola that we feel comfortable with, y equals a times x minus squared plus k. Now my a value is 1 over 4p. My h is 0, as is my k. So I can write this easier or more efficiently as y equals 1 over 4p squared. Now I multiply both sides by 4p. I get 4py is equal to x squared. And then insert the standard form of parabola with a vertex 0, 0 and a vertical axis. Follows that if we have a parabola with a vertex at the origin, but this time we have a horizontal axis. So notice in the picture I have a vertex at the origin at 0, 0. My focus and my directrix are each a distance of this distance we define as p. Therefore the focus would be the coordinate p comma 0, and my directrix would be x equals the opposite of p. We now have a horizontal axis. So the standard form of its equation is y squared equals 4p times x. And hopefully you're noticing a pattern that in the previous picture, we had a vertical axis, and so the x was squared. Now that we have a horizontal axis, then the y is squared. So now let's move the vertex to some other place that is not the origin. So let's say I draw some arbitrary vertical axis, and we'll call this x is equal to h. And then I'm going to have a directrix here. I'll make this the vertex, which is hk, and then my focus would have to be an equidistant value of p. So I have some type of parabola that's doing this. The equation of this in standard form is x minus h squared equals 4p times y minus k. I'm not doing the formal proof of that, but it should make sense by pattern that I'm squaring the x value stuff, and the 4p is being multiplied by the y stuff since I have a vertical axis. Now, you don't, in my opinion, have to memorize these formulas. When we do some examples later, it should become clearer. But if I want to think about what is the focus, the x-coordinate of the vertex, it's on that axis of h, but then it is p units above k. So the y value is k plus p, versus my directrix is going to be a k value minus p. And this formula is true for when p is greater than 0. This value right here is positive. Therefore, I have an upward parabola. So now, if I would do the case where p is less than 0, I want you to note that your form does not change. What this is saying is that if p is 0, then that means that this is a negative value. So that when I would draw my corresponding picture, I would still have a vertical axis of h. I would have some vertex hk. I would still have a focus where this is a distance of p to the directrix, but my parabola would be downward. So when people ask, well, why does this work? Since p is less than 0, it's a negative value. My focus is still going to be the h value, k minus a negative p, which would put it as positive. And then my directrix would be y equals k minus a positive p, so you would still get x minus p as a value. So it follows if the parabola has a vertex other than the origin with a horizontal axis, and I've drawn a picture of that here, where here I have a vertex hk, and it is a distance of p units each from the directrix and the focus. Notice that because I have a horizontal axis, I'm squaring the y values. And this is true for when your p's are greater than 0. So again, this is saying that this value is positive. So that means your parabola would open up to the right. And my focus would now be h plus p. So it would be p units past my h value, but would remain the same k value. My directrix, however, would be x equals the h value minus p units. Down below, notice how in this case p is less than 0. So again, the vertex is still a distance of p, but we're assuming p is a negative value, causing the opening of the parabola to open up left. So your focus would still be h minus a negative p, which brings it to positive 0, and my directrix would still be x is equal to h minus a positive p. All right, let's try example 1. All right, on example 1, we're going to find the vertex, the focus, the directrix, and we're going to sketch the graph of y equals negative 4x squared, and we're going to do this without t-charting it out. Here are some things that you should notice by just looking at y equals negative 4x squared. First of all, notice that it is the x value that's being squared. Since the x value is being squared, this should automatically tell you that you have a vertical axis of symmetry, which means this particular parabola is going up or down. Because I have a coefficient that's negative, that should alert you that this should be going down. Next, because I don't have anything of the form x minus something squared or y minus something squared, this should tell me that my vertex is at 0, 0. So let's sketch. Here's what I know so far. I know I have a vertex here at 0, 0, and I know it's going to be going downward. This is what I know so far. All right, now let's use the form, standard form, 4py is equal to x squared, is our standard form of a parabola using the locus definition. Well, if I look at what I have, we don't want the coefficient in front of the x squared, I want it in front of the y. So I'm going to multiply both sides by negative 1/4 so that I get negative 1/4 y is equal to x squared. So now what this allows me to do is I can match up that 4p is equal to negative 1/4, and if I want to solve for p by dividing by 4, remember negative 1/4 divided by 4 is the same as multiplying by 1/4, we get that our p value is negative 1/16. So that means I have to go a distance of 1/16 above and 1/16 below to get my focus and my directrix. Well, if you know that your focus is a point that lies on the inside of the parabola, then this should tell you that at 0, negative 1/16, that is going to be the point of my focus. My directrix has to lie 1/16 units above the vertex. So it is equal to y equals 1/16. So again, my vertex is 0, 0. My focus is 0, negative 1/16. My directrix is y equals 1/16. And then this is a rough sketch of my parabola. So welcome to example 2, where we are going to basically do the exact same thing, but with a little bit more challenging question. We need to find the vertex, the focus, the directrix, and sketch the following parabola. So notice I have x minus 5 squared plus y plus 4 squared equals 0. I should notice that because the y value is being squared, this tells me that I have some kind of horizontal axis. So if I have a horizontal axis, it means that the parabola is either going to open up left or open up right. I'm not able to directly make that decision right now, but we will shortly. Also, I know that 0, 0 is not the vertex because I have x minus a value, y plus a value. So let's put this into our standard form. Remember, standard form is y minus k squared plus, equals 4p times x minus h. So that means I need to take this entire term and I need to pop it to the other side. So this yields y plus 4, the quantity squared, equals negative x minus 5. So now I'm in standard form. So my vertex is going to be 5, negative 4, because they match up. And another way of thinking of it is you take the opposite of what sign is inside the parentheses. So let's plot that. I'm going to go to 5, negative 4. So there's my vertex at 5, negative 4. Now, notice that my p-value is going to have to be less than 0. So that means that this parabola is going to be opening up to the left. Now remember, this was my axis, my horizontal axis right here. This is my axis. So now when I have to determine my focus and my directrix, I need to figure out the p-value. Well, 4p is equal to negative 1, so my p-value is equal to negative 1/4. As a distance, we use its absolute value. I need to go a distance of 1/4 to the left and 1/4 to the right. The focus is what lies on the inside of the parabola. So if I think about what that coordinate has to be without using any formulas, I know that it still lies as negative 4 on the y coordinate, but it's 1/4 less than 5. So it's going to be at 4 3/4, and as an improper fraction, that's going to be 19/4. My directrix is going to lie 1/4 units to the right of the vertex. So that means this is going to be x equals 5 plus 1/4, or x is equal to 5 1/4, or 21/4. So the vertex of this equation was 5, negative 4. The focus was 19/4, comma negative 4, and the directrix was 21/4. Again, you could refer to all the formulas we did before, but I think that's a lot of memorizing. If you understand the locus definition of a parabola, where the vertex is, how the vertex is related to the directrix and the focus, by graphing it and using your brain, you should be able to figure those out. So here's example 3, same directions, but what's changing is that my equation has gotten more complicated. I don't see just a single x squared or just a single y going on, so that means the origin is not the vertex. And I don't see any parentheses going on, so I'm not real clear on what to do. The only thing we really can determine is because my x is being squared, this tells me that I do have a vertical axis, which means this graph is either, the parabola is either opening up or the parabola is opening down. So what do we have to do? Well, we need to somehow get this into standard form of x minus h squared equals 4p times y minus k form. That's where we're headed. So in order to do that, I'm going to subtract 8y and 9 from both sides. Why am I doing that? Well, it doesn't make a difference what's kind of happening over here with the y, but I have a linear term here for an x, and I don't see any room for a linear term in here. So I need to find some way to get this to be a binomial squared. So when you have a binomial squared, it stems from a perfect square trinomial pattern. So in order to make this be a perfect square trinomial, I have to complete the square. So to complete the square from Algebra 2, you have to take the linear term, divide it by 2, and square it. So this is negative 1 squared, which is 1. And whatever you do to one side of an equation, you must do to the other. So this helps me determine that this side would factor into x minus 1 squared. This side becomes negative 8y minus 8. And so when I have x minus 1 squared and factor out a negative 8, I now have this into my standard form, x minus h squared equals 4p times y minus k. And now I know that my vertex is going to be the opposite of 1, and then the opposite of positive 1 is negative 1. Because my p is negative, this tells me that this parabola is going to have to open up downward. Okay. Now this was my axis. Here's my axis, vertical axis of the parabola. So again, 1, negative 1 is my vertex. And if I take 4p and set it equal to negative 8, that p distance is negative 2. So I have to go a distance of 2 units to get to my focus, and I have to go a distance of 2 units to get to my directrix. So this means my focus, its coordinate, would still have the same x-coordinate of 1, but it moved down 2 places, so the point of the focus is 1, negative 3. And then the directrix, its equation, would be y is equal to 1 because it would have gone up 2 units from negative 1. So again, here is a sketch. Vertex of 1, negative 1. Focus is 1, negative 3. Directrix is y equals 1. For example 4, we're going to write an equation of a parabola in standard form if you're given that the vertex is the origin and the focus is 5/2, 0. So some of you might be able to do this without a sketch, but I tend to sketch because if I can see what's going on, I don't need to memorize, and I can just use logic to figure out what's happening. So my vertex is the origin, and my focus is 5/2, so that's 2.5, 0. Well, we know that the focus has to lie on the inside of the parabola, so this means that the parabola has to be opening up to the right. This immediately tells me that I have a y squared. So my general form, our standard form of this parabola is y squared equals 4p times x, because I have the vertex is at the origin. And I want to find out, well, I need to know what this p-value is. Well, the p-value here is 2.5. So I'm just going to take y squared is equal to 4 times 2.5, or 5/2 x. So that means y squared is equal to 20/2 x, or my final answer, y squared is going to equal 10x. And that is the equation of a parabola in standard form if the vertex is the origin and the focus is 5/2, 0. On example 5, we're going to do the same thing. We're going to write the equation of a parabola in standard form if you're given that the vertex is 3, negative 3, so we're not at the origin anymore, and that the focus is 3, negative 9/4. So let's see what's going on. Okay, if I plot those, the vertex is at 3, negative 3, and my focus is at 3, negative 9/4. So that's negative 2 1/4. So negative 2 1/4, it's going to be slightly above. So again, if this is my focus and there's my vertex, then I know that this parabola has to be opening up because the focus lies inside the parabola. So this automatically tells me that I have a vertical axis, so it's the x values that need to be squared. So the standard form that I'm going for is x minus h squared equals 4p times y minus k. So I know that the vertex is 3, negative 3. So I'll have x minus 3 squared is equal to 4p times y plus 3. And now all I need to do is determine what that p-value is and multiply it by 4, and I'll have my final answer. Well, again, if my vertex was at 3, negative 3, and my focus was at 3, negative 9/4, then the difference between the two, or my p-value, was a difference of 3/4. It is going to be a positive value because this is opening up. So I have x minus 3 squared is equal to 4 times 3/4 times y plus 3. And when I simplify those values, I get my final equation of x minus 3 squared equals 3 times y plus 3. And for our last example, on example 6, we're going to write an equation of a parabola in standard form if the vertex is negative 2, 1, and the directrix is x equals 1. So let's see what's happening. Let's draw my sketch. My vertex is at negative 2, 1. My directrix is at x equals 1. So this is what this tells me. Obviously, because my directrix is vertical, I have to have a horizontal axis. If I have a horizontal axis, then that means the y values are being squared. It means it's opening up left or right. And because the directrix is to the right of the vertex, then this has to be opening up to the left. So, putting all of this together, I need to use the equation of a parabola in standard form. That's y minus k squared equals 4p times x minus h. I know that my vertex, so let's pop that in, is x minus 1 squared, 4p times x plus 2. And I know my p-value has to be the distance from the vertex to the directrix. So if this is at negative 2, 1, and my directrix is at x equals 1, then this distance from here to here, this distance 3. So let me pop that in. Y minus 1 squared is equal to 4. Now, because it is opening left, this means my p has to be less than 0. So I need to pop in a negative 3 for p. And my final answer is y minus 1 squared equals negative 12 times x plus 2. So you are now ready to begin the following assignment, which is on page 637. And try 1 to 45 the odds. Good luck. Let me know if you have questions.